So in this second example, it's essentially a more complicated version of our first example. So instead of going to a jewelry store, we are purchasing gold coin through a broker, and he charges 5% of the face value, and this transaction occurred through postal services, and the courier service charge is $28. So again, let's think of this process in terms of input and output. So we have our input and we have our output, and again we have our transaction fees, right? So our input is actually unknown, so we don't know what our input is. We know it's in the form of money, but we don't know what it actually is. So let's call it X. The transaction fees are in two forms. We have the broker fees and we have the courier fees. Our output for this example, let's say, is one gold coin that weighs 1 ounce of gold. And from our exchange rate, we know that that's equal to $1,260. So what's our question? Our goal is to determine the efficiency of this process. So that's our goal. That's what we're driving towards. So we don't know what our input is. We know courier fees are $28. Our broker fees, we know in percentages is 95%, but we don't actually know what's that amount in money. So we're going to solve this problem in two steps. In the first step, we're going to assume no courier charges. So we're going to simplify this problem, and we're going to say step 1, assume no courier charges. So again, let's do this process again. We have our input, we have broker fees, we have our output. Our output is same, $1,260. Our input in this example, let's call it Y. Our broker fees are actually unknown, but we know, what do we know? We know the efficiency of this process. We'll call it NB to represent efficiency of the broker transaction is 95%, which is given in the problem statement. And the efficiency is simply output over input. So our output is $1,260, and our input, let's call it Y. So we know that the efficiency of this transaction is 95%, so our unknown here is Y. So Y is equal to $1,260 over P is equal to $1,260 divided by 95%, and I'll just multiply by 100%. So Y is equal to, if we calculate that number, it turns out to be $1,354. So So the other thing we can determine from this steps is the broker fee. So the is equal to it is we just determined $1,354, and our output is $1,260. So broker fees we know is $94. So in the step 2, we solve this problem. We solve the main problem where we include the career charge. So we have input. Our input is unknown, or is it known? So we determine our input in this example, this Y, was $1,354. The question you might ask is if that's the same input as this one. And the answer will be no. This input is different from that input. And the reason is, in this case, we assume no career charges. So if we include the career fees, our input will increase, right? We have some of our input going to career charges. So our input in this example, which we are calling X, is equal to our input in this example, which was Y, plus the career fees. So if we substitute in for Y, which is $1,354, our answer comes out to be $1,382. So that's our overall input, assuming making no assumptions regarding the career fees. So now we know our overall input, we know we have our output, and we can determine our overall efficiency. So our efficiency, again, in this case, is output or input. Our output is $1,260, same as before. Our input now, including the career charges, is $1,382 times 100%. If you plug in the numbers in the calculator, you get 91%. So, a couple of things to highlight. When you're solving problems like these where you have multiple transaction costs, it's always good to simplify the problem. So in this case, we simplify the problem assuming no broker fees, and then in the first step, or assuming no career fees in the first step, and then we included those fees in the second step. It's good to think of problem in terms of input and output. And remember, your input might be different depending on if you make any assumptions regarding your transactions. So if you have two sorts of transaction cost, and if you, for the purposes of simplifying the problem, you assume you eliminate one of the transaction costs, your input will be different. Your output, if it's given, is the same in this case. So our input, assuming no career charges, is 95%, right? Our efficiency, assuming no career charges, is 95%. If we include career charges, our efficiency goes down to 91%. So the question for you guys, just to make sure that you understand this concept, is how will the efficiency change if you're purchasing 10 gold coins? Screen. And that's all from this video.